Hi, I'm very excited to give an introduction to my Shiny context entry, which is called Previewer. This application is used for previewing multi-varied data sets. Some people call it multi-dimensional dataset in terms of measurement, but I'm just calling it multivariate dataset. When it's launched onto the Shiny server, you could view this website called shinyapps.io slash previewer. And then you could play with the application. So the main panel has a lot of parts. So the first one is the plot and variable summary. You get data and model data outputs, considerations, which most of the part is for future implementations, and relevant code to generate such operation. So you can start with different data sets. So if I click on select data set, you could browse within the provided data set in R and R Studio Cloud. And you could also use the keyboard to type it. So in this case I type iris, so it automatically generates a preview. Or you could browse your local file to upload a CSV or TSV. Sorry, it's a tab separated value sheet, and you click on use uploaded, and it reads the custom file. Instead of giving a fancy presentation for data, this application focuses on a more systematic and reliable approach, which is combining the visual and variable summary and model data and other considerations code together when you're previewing the data. So you can do lots of different things from previewing the data set to training your ML models, I mean the simple ones on top of it. It covers a lot of different aspects. So I can select different visualization method. For example, I'm using preview here. So it's showing the pairwise plot, which is generated by this function. I can color this by like different variable, but I would recommend you to color the plot by a discrete or categorical variable. So you can find the variable type here. So this data set has four continuous numeric variables and one factor, which is identified as categorical variable, but it doesn't restrict your ability to use categorical variable as a numerical variable or vice versa. So I can change the color, but with a preview thing, I can't really do much. So I can do exploratory 2D plot, which is pretty much the same. And I can do correlation plot with correlation matrix. And similarly, the data and model data shows the correlation matrix, and also the so-called symbol of numbers. So the symbol of number matrix is sometimes more clearer than this one, because it gives a symbol instead of forms. So some people would prefer this form, some people would prefer other form. The code, this corresponding code is also shown in the panels. So the importance of getting a pairwise correlation matrix is that it lets you identify what pairs of variables represent very similar variations. So you may consider some transformations like reducing the dimension before actually working on the data. And likewise, you can do principal component analysis. So this is a PCA for the individual observations. It analyzes like which part represents the most variations and which part represent slightly like a secondary variation. But like I mean the point of PCA is to use a singular value decomposition to decompose your variable. And by default, it use centered and scaled data, so you won't be affected by the skewness too much. The color by default is the contribution of each data point towards the total variance. I'm using the like a GG and the grammar of graphic ends to support the graphics, but I'm also using the spectral like color. I'll explain the reason later. So this lets you see that the first dimension takes up 73% of the variation of the first of all the variable, and second dimension is here. However, you can't really see much. So if I go to data and model data, it gives me the actual value and the actual output of the transformation, which is like a more informative way to examine this thing. You could also do a number of different exploratory models. For example, I can do summary by column, by box and whisker data. So all of the plots follow a kind of minimalistic style. So you can see it's green and the right red, which is a kind of contrasting color. So this plot is nothing much but doing a summary, because it's taking the column-wise summary of one dimension. Similarly, you could do histogram and density. I'm using quite large number of boxes here, so it's similar to the previous plot. And you could also show the variable summary. The data is not much; it's just the variable summary. So I don't really want to duplicate that. You can do something creative with a lattice. So this is called parallel coordinate plot. So each line represents a observation instead of a connection within the observations, and each row represents a variable. So it's showing how the things are distributed. You won't see much from this iris dataset because it's just because of the physical essence of the dataset. But I can use it to browse some other datasets, like the MPG dataset, which is about cars, I believe. So it's showing car models and manufacturers, and you see some interesting patterns. Maybe something are like some a cylinder type, or is it horsepower is related to. Is binded to, it's like somewhat more binded to each other or not. What you can also do is color by group, which I believe you can color that by manufacturer. So it's showing your different type. So if I go to the iris data set, if I want such parallel plot, I can actually color this by species, which is kind of nice because like the blue is one species, the purple is another, the green is the third one. So you can see the different species has different linked other variable that you must consider when you are analyzing the data. So this is actually from Lattice, not from ggplot based packages. If I go on to explore other functionalities, I can be more flexible if I use it with the GG grammar. For example, I can show 1D summary with pivot tables. So in this way, I must specify some kind of variable to use as my histogram entry. So it's, for example, sepal length. So I can use like one variable with this one. So actually I can't really color by species here. Or can I? Oh, okay. Species, and y is sepal. So this is actually a 2D thing. The first dimension is your species. The second dimension is sepal length. However, it's not great to use a continuous coordinate to represent a discrete variable. So I can use group here to represent species. So like it's actually, you can see that it's using the set property of ggplot, but it's using a minimalistic theme, so I can be consistent with the colors. If you click on the data and model data here, it's actually giving a pivot table of the it's actually giving a pivot table just like the one in the what is it called, Excel. So if you're heavy Excel users, you might find this useful. So it's putting a summary for each group. So this one is a summary for Setosa. This one is from the summary for versicolor. This one is summary for Virgin. Sorry for my pronunciation. Anyway, so I'm not a biologist, so I can get rid of the complex things when it doesn't matter, I guess. And it's also giving you a analysis of variance. So AOV, it's kind of examining whether the group matters for the distribution of one variable. So you could kind of examine the output. However, it's also nice to, I think it's also nice to check that the variances of the three are kind of similar. So I may add the variance of the standard or the standard deviation of the three, the same measurement of the three categories in the pivot table. Maybe it would be better for you to examine this one, and you can see the actual code. It won't be exactly the same, but you could get it working with very little modification. I'm just showing you how convenient this is, because the application is actually coding for you. Okay, so it's kind of working. I can also color this by species. Is it nice? No, I can't really do this. Color by sepal length. It doesn't really work because I'm measuring the sepal length, right? It's only the jitter that is working, but it doesn't matter to me too much, because there's other things I can do. So for example, I can do one-dimensional density curve. Instead of using y as the variable, I can use x as the variable, because a density curve looks better when it's horizontally presented. So I can use sepal length as this one. However, it's not really. I don't really want to use this one, so I can color this by species. If I color this by species, you could see and compare the density of the three, the density of the distribution of the three things, and as usual, the transparency is pre-designed, so it avoids the effect of the overlap. And the interesting thing is, when you plot data and model data, no matter if you use density or use histogram, as long as you use the the correct measurement and the correct groups, it also gives you a nice little this is called pivot table. So it also works. No matter if you want to use density plot or histogram, it always works. And something I forgot to say is that you could actually group this by several variables using the facet and using the facet table, and also using the group by function in the dplyr. But I think it's better to use I think it's better to kind of use a data frame with more variables. So, for example, I'm investigating this variable in MPG dataset, and I want to color this one, maybe by manufacturer. And the first group I consider is the manufacturer. The second one I consider is the maybe class. So it's giving you this kind of density plot. Whenever this is the plot, it doesn't look pretty nice here. You could use the summary with the with the what is it called with the a box and whisker plot. So in this case, I'm investigating the same variable. I think I screwed something up here. Does it work? Okay, so data and model data. You could oh, sorry. I think okay, so when they group by two variables, sometimes the like summarize function doesn't or group by function doesn't work properly, but the facet but the facet functions still work. However, it's also good to be aware that when you get many plots on the same page, it sometimes looks quite confusing. I'm using the function to minimize to like use a minimalistic form of the plot, so it could look cleaner. But if you got too many variables, sometimes it's pretty much the best we can do. So the code here, I think the code here still works, apart from the pivot table for like the interaction of two variables. But we can do two groups interactions with some permutation later. What I'm going to show you is the second good thing about this one. It's called 2D models. I can use like a cylinder and HWY to create two variable plots. So this is two variable plots with classification of those groups, and also I can color this by the number of cylinder. I can color this by cylinder. So, but because it recognizes the cylinder as I think as a continuous variable, or the variable with a lot of different colors, it's actually giving a very complex scale. For the 2D cases, we can use the linear correlation as the data and model data, but this is thought to be a feature to be implemented in the future. So 3D plots, you must have three variables. The three variables should be numerical variables. So I pick from the numerical variables that I'm interested in. So to be systematic, I'm choosing from maybe CTY, this variable here, and you can't really group it because it's using another function. But the nice thing is that I can still use color. So if I want to color this by like the cylinder, this is using a different backend because ggplot 2 doesn't support 3D. So I'm actually using a function from plot3D package. So you see this is working, but the code and data isn't so perfect. 3D plot is better when we view some more continuous variable. So if I use this iris package here, iris dataset. So I can do a sepal width, length, and petal width. I can color this by either a variable that's in the scope of this function or outside this function. So I can color this by the z values of petal length. So this is petal length, or I can also color this by a value that isn't represented by the 3 dimensions of the plot, which is kind of great. Not very perfect, but this is a humble start for a systematic approach. I think we could train models on this, but you have to specify which model you want to train. So there's a little button, use all variable as predictor. So if I click on this button, it's using all the variable. If I don't click on this button, it's using all the variables specified this in here, not counting those null variables. So you could train models, predictive models with different types. I think caret default is using what is it called? A random forest. Is it random forest? So some models doesn't allow classification, or some model doesn't allow regression for numeric variables. So you have to be specific with that. C50 also maybe yeah. So neural network, you could train that for sepal lengths with respect to other variable in this one. It's great to do. So if you look at the code here, it's actually using cross-validation to check the overfitting problem. Although admittedly, overfitting problem cannot really be ignored. Even if you are using CV, when you have small sample of this thing, I can view the model performance by using RMSE, or I can also view the model insight. Some packages isn't supported by the visreg package, so I think I'm not using a perfectly good example. So if I use species, and I use, for example, C50, and I want to use, that's kind of awkward. So the model insight, I think in which cases work. So in some cases, so transmission with 50 doesn't really work. Model data, model insight. Oh, really? I have to fix that after doing this. So the model insight is using the package called visreg, specializing regression to do all those models. So this So this application here is a let's say it's like a combined approach to preview data with different aspects, considering both visualization and those parameters and the use of transformation models and statistics statistics test to preview the data to see if there's any weird things or not from the model. Yeah, it pretty much does that. Don't expect too much from it. Yeah, overall, it's I don't know. So feel free to play with this program. I will leave the program in the. I will leave the source code on my GitHub, and you can see this is a Shiny RStudio Shiny contest entry for this year, which is a humble start for a like a more systematic view of the data, combining the functionality from a lot of different packages, not only the ggplot, but lattice, misc 3D, visreg, and caret. So yeah, so that's yeah. Thank you for your thank you for watching.